All right, so in this problem, we're trying to find the one-sided limit of this function. So we have the limit as x approaches 0 from the positive side of the secant of x over x. So one way you want to always keep in mind when you're dealing with limits, even if they're one-sided limits, first check to see if you can just plug the number in. If you can, then you're pretty much done. Whatever number you get is your answer. Now here, if you were plugging 0 on the top, secant of 0, you get 1. But if you plug in 0 on the bottom, you would get, obviously 0. So you're going to have an undefined expression. So we can't simply plug in 0. So we got to do something else. So what we want to do is understand what's going on as we're getting close to 0 from the positive side. Now I'm just going to draw a graph of each of these so we can get a sense of like what this looks like. But once you can visualize this stuff in your head, you won't have to. So let's review what the secant of x function looks like. So the secant of x function, if you remember from trig, secant of x is the reciprocal of the cosine function. So it's 1 over the cosine of x. And so then at 0, it's going to be equal to 1. So you have a point at 0, 1. And what it's going to do is going to have these upside down, parabola looking things, and you're going to have asymptotes at pi over 2 and negative pi over 2. And it's going to do the same sort of thing to the right of that. And I'll keep on repeating this behavior. But we don't really care about what's happening, beyond that. We really care what's happening over here. So if you look at this graph, when you're coming to 0 from the right side, the positive side, you're on this side of the graph. So you're basically getting very close to 1. The value is going to be 1. So you'll essentially have, 1 over something. So you have to figure out what's going on when you're approaching 0 from the positive side of the graph of x. So in other words, it's the graph for y equals x. So just again, treat this as another function. Like treat the top as one function and the other as a function as another function. So we can say like g of x, we'll say is equal to x. And that's just your common linear graph that goes through the origin, which is this, And if you're coming from 0 from the positive side, you're gonna have a very small positive number. You're getting very, very close to 0. You're not gonna actually get to 0, but you'll get a very, very, very small number. So like maybe let's just go 0.0000001. So when you take 1, even though 1 is a relatively small number, in everyday life, when you take 1 divided by something like this, the number is going to get so large, it's going to get infinitely large. So let's just look at what I would get. If I plug in that, you'll get something like 100. I don't even know what that is. It looks like 100 billion or something, a large number. So the smaller I make this, the larger this gets. So we can say that this is essentially going to go towards positive infinity. So your limit as x approaches 0 from the positive side for this expression will be infinity.